The world's gotten a fair amount better about making sure that anything that can fit into a socket doesn't automatically make something explode, but Allen Bradley in particular back in the day used to have a type of port that used an RJ45, which looks an awful lot like an Ethernet port because an RJ45 is an Ethernet port. But if you were unfortunate enough to not understand that you were not looking at an Ethernet port, you could plug in your laptop, and I believe the voltage on the Allen Bradley side was considerably higher, and so it was your laptop port that would be, in all likelihood, well, destroyed. So yeah, don't plug into that. Hello, and welcome to Chaos and Controls, the show where we talk about modern devices, technology, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor. Today, I thought we could go ahead and talk a little bit about the different types of I/O that are out there, and how you might use or not use them to, well, automate your home, business, or life. So without further ado, let's talk about the different types of I/O that are out there. Now, I know in previous episodes we've talked a little bit about the difference between inputs and outputs and analog versus discrete, but it may surprise you to know that there are actually different types of even, just discrete or just analog inputs and outputs. So, without trying to say that this is going to be an exhaustive list, I thought I'd go ahead and talk about some of the most common types. Now, in industrial automation, you're going to find that most things really like to use 24 volts for whatever reason. And even still, a lot of your sensors and your inputs, you're going to have the option for a discrete input that either sees 0 volts or 24 volts to get you your 0 or 1 on or off, yes or no kind of answers. But you could also have a 0 or 120 volts. And so if I have a 120 volt signal, that is a on, and a 0 volt is off. Subsequently, usually when you see a 24 volt system, it can be a DC system or an AC system. I suppose technically that would be the case on the 120 side as well, but you almost exclusively, at least stateside, see 120 volts AC. So we can have AC and DC, we can have 24 volts and 120 volts. It's also common enough in something like a car circuit. You might have a 12 volt input card. If we are utilizing an Arduino or an ESP32, you might see either a 3.3 volt or a 5 volt DC input. No reason those couldn't be AC either. On the analog side, things get even more interesting, where we can have a voltage detection, and that can be 0 to 24 volt, or much more commonly is a 0 to 10 volt for your analog. And so on a temperature sensor, you might have 0 volts is mapped to maybe 0 degrees Fahrenheit, and 10 volts is mapped to 150 degrees Fahrenheit, and it's a linear progression in between. You might also see a 0 to 5 volt, again for something like an Arduino or an ESP32, or even a 0 to 3.3 volt depending on your particular system. Those are normally going to be DC values, and that is the more common for anything 24 volt and below to use DC, particularly 12 volt and below to use DC, but there's no reason that you can't use an AC voltage. Additionally, in the industrial side, you are very likely to see either 0 to 20, or if you really want a robust system, you can use what's called a 4 to 20 circuit. And 0 to 20 or 4 to 20 is looking at current instead of voltage. And the reason for that is if I have a particularly long line, I have voltage drop across the resistance in that line, and so the longer I go, the voltage signal that gets back to my controller decreases, and so for particularly long runs, I may not have an accurate reading of what's going on in the field. Current, however, is the same anywhere in the wire, so if I have a transmitter that can do 0 to 20 or 4 to 20, and I would use 4 to 20 because then I know if I map my 0 condition to 4 milliamps, if I'm getting 0 milliamps, my wire's been cut. But in any case, the fact remains that if you are sensing current, the length of the wire is somewhat irrelevant because the current is the same everywhere in the loop. And so in industrial systems where we really need to be in control of the process, I can see precisely what my analog value is coming in from that transmitter because the current is the same all the way out in the field as it is back at my controller, which isn't necessarily the case for voltage, particularly on long runs. In any case, this is hardly an exhaustive list, but I've hopefully hit all the buzzwords for things that you are likely to see out in the world. It's also worth noting that you can have syncing or sourcing inputs and outputs, and that really is just kind of the difference of whether or not we are supplying the voltage slash current or if we are simply receiving it. If we are supplying it, you're going to have a much beefier controller with a better power supply, so on and so forth. There's a lot of nuance that goes into all of these, and I highly suggest that whatever system that you are working on, you go ahead and try to find additional supplemental information on all of these, but hopefully we've at least covered all the buzzwords so that you understand what's going on. In any case, that's about all I have for you today. You all have a good one, stay curious, and we will catch you next time.